working on, like with all my work on it and stuff.
Okay.
I didn't know how to do 12 through 14.
I didn't even see a 12 through 14 here.
Did Mom not scan it? Mom,
well,
oh, you're kidding me. Mom, you didn't do it. You didn't scan the right one. You were supposed to scan it. Yeah, tell him to look at the second email. Oh, okay. Look at the second email. Why did you pull it apart? Oh.
Okay.
Is there another paper in there? Did you forget to take it out? The scanner?
And let me see if I have a second email. I do have a second email.
Okay. Sorry. Okay, it's okay, Mom. Sorry.
Let's see. The second email
Okay, it's okay. It's fine.
says, whoops, this is the one to use. Is that the one I want? Yeah, let's see.
Yeah.
Okay.
Okay.
All right.
Okay, we're good.
So 12 through 14.
And the first four I was having trouble with. I think I might have done them wrong, right? But I'm not really, I couldn't really tell.
The first four on this page?
Yeah.
Well, let me go up and have a look. We might as well check. Okay, one is correct, as all you do is multiply the exponents. Two is correct. Whenever you have a negative exponent, is all you do is move it to the other side of the fraction bar. So 3, the correct answer is xy to the third in the numerator only.
All right.
Okay? And that's the way to always, that's one way of always handling negative exponents. Whether they're in the numerator or the denominator, you can just put them on the other side of the fraction bar.
You see the answer to it. It might be wrong, so.
You've got x cubed, y cubed plus 1. It's not the plus 1.
No plus 1?
No plus 1. In other words, if I move that to the numerator, I am multiplying it by 1.
Okay.
Okay?
So the 1 just disappears.
Yeah, you don't write it. It's just x cubed, y cubed.
Okay.
Okay. Number 4, let me take a quick look. The way you handle these kind of problems is one variable at a time. You do all the x's, you do all the y's. So when I do all the x's, I get x to the 4th. When I do all the y's, I get y to the 14th. Okay, good.
Okay.
You direct me. Where do you want to go next?
Could we do which ones didn't I do? I didn't do 11 or, I did 10, but I didn't do 11 or 12.
Okay, let's look at 11. Let's talk about 3 types of difference or sum of squares and cubes. A squared minus b squared is difference of perfect squares. What's that equal to?
I guess it would just be a minus b and a plus b.
Correct. And I like it when you memorize it in that order, and I'll show you why. A cubed minus b cubed is what?
Wouldn't it be a binomial and a trinomial?
Well, the first term always, it's the same sign as this. And the second term, which is your trinomial, is what? Do you remember?
Wouldn't it be the, what you call it?
A squared, and the next sign is the opposite of the first sign. So it's plus AB plus b squared. Okay?
Oh, I
Well, that's going to apply to this problem because there's one third one, and it's the sum of cubes, perfect cubes. You can't factor the square of you can't factor the sum of squares, but you can factor the sum of cubes. And the first term is the same sign again. And the next term is much like the above, only opposite sign in the middle.
Okay, so you make it, what is it? The first one's opposite and the second one's same, right? Like not the first one.
It depends. Let's look at one at a time. Okay, when we're talking about the difference of squares, the first term is a minus b, same as that negative sign. Second term, opposite the first term. Same thing with difference of cubes. The first term is linear. It's the same sign. They're both negative. And the next term is definitely a trinomial, but that middle term is the opposite of the first negative. It's positive. Same on sum of cubes. The first term is linear with the same sign as what you start with. Second term is opposite of the first term in the middle, but the two end terms are the same as those above. And you need to memorize these, and this is the best pattern I have found for memorizing them. Okay? Now, 8y cubed plus 1 is the sum of perfect cubes. In other words, that is a perfect cube, and that is a perfect cube. What would a and b be for this? What would a be?
It would be 8y.
It's the cube root of this. Take the cube root of that.
2.
2y.
No squared?
No. In other words, 2y cubed would be 8y cubed.
Okay.
Okay, what's b?
Just 1, right?
Right. Okay, now let's go and apply it down here in this third one. So what we have is a cubed plus b cubed. So we need to separate it into what? What would the rest of it be?
Binomial and trinomial.
Well, fill it in for me. In other words, this first linear term is going to be what?
The first term is going to be 2y plus 1, right?
Correct. What's the next term going to be?
Wouldn't it be 4y squared? And then you go to the last term, you skip to the last term.
Hold on, there's a middle term here.
Oh, you can do it like that too, I guess. Well, yeah, I was just thinking you do the last term and then you go back to the middle term. But I guess you could do
okay, I don't care. I always go left to right and maintain a certain methodology when I'm working all my math problems. But if you're used to going to the third term, that's fine. That's a plus 1.
Yeah, and wouldn't it be, it would be a times b for the middle term, so wouldn't it be 2y just in the middle?
If I write that, does that make sense?
Well, you have to put minus 2y.
Okay. That's needed. In other words, whenever you're talking a polynomial, you have to have a sign, unless it's the first term of the polynomial. If it's a middle term, you always need either a plus or a minus. If you write it without a sign, it makes the whole thing meaningless. So that's your answer. Okay.
Does this method apply to number 12 also, or no?
Well, let me have a look at 12. 12's an interesting one. I don't know. I don't know that it would. I don't believe 12 is any of what I've written here. However, we can probably do 12. We're just going to have to play with it a little bit. Let me I'm inclined to think that you'd be better served if we come back to 12 if we have time.
Okay.
In other words, you have a lot of stuff to cover here, and 12 to me looks like it might be the hardest thing on the page to cover.
Oh,
so I would say rather than us spend 15 minutes on 12 or 10 minutes, let's go on. A 12 is going to be some combination of C minus D or C minus some number of D times maybe 3 terms, 3 linear terms. It looks like it would be, and I would just have to play around with it and kind of experiment to come up with it. Whereas I hate to do that if I'm not 100% sure I can come up with it. So let's go to what next? We'll come back to 12 if we have time.
Could you look over my work on 14 and tell me if I did it the right way?
Okay. Solve the equation. Okay, so first we want to move everything to one side and then factor out a greatest common factor. It looks like you've done that. Yeah. Yeah. Let me keep going. So now the one thing you've left off here is you need to put equals 0 on the other side.
Oh, I put, well, I made y equals 0 in
In other words, at this step right here, in fact, your very first line, what you've written is an expression, and what you started with was an equation. So you need to keep it an equation and put equals 0 there. I don't know if you'd lose points for that or not. Maybe, maybe not. All of them should be like that. And then the last line, or this line right here, can you see where I'm pointing?
Yeah.
You should still keep the 4y squared in there, and the whole thing is equal to 0. Don't get rid of it yet because it's one of your solutions. I see you have y equals 0 down there. Well, that comes from that 4y squared. That's why y equals 0 is a possible solution. But yeah, the rest of it, hold on a minute. You know what you should have factored out?
What?
Oh, and you did in the next step. Okay, good. Instead of factoring out 4y squared, factor out negative 4y squared. You just did it in 2 steps, which is fine. Yeah. But this y equals 0, a lot of people miss this solution just because they're not thinking about it. But for sure, if this whole thing's being multiplied by some number of y, then y equals 0 is part of the solution set.
Could we work on 15? Because I didn't do that one.
Yeah. Let's see. Let me write it over here and see if I can figure out an easier way to do it than to expand it. Although we can certainly expand it and then combine everything and see what we have. And I think that's going to be the only way to go. Yeah, there's nothing we can divide both sides by to reduce anything. So let's expand it. Tell me the next line. First of all, let's talk about something.
Yeah.
This is a process you're going to have to do 1,000,000 times over the next couple of years, which is to expand a binomial, both the plus and the minus. You should learn how to do it quickly. And by that, I mean you can FOIL this. In other words, that's 2x squared plus 3 times 2x squared plus 3, right?
Yeah.
that's kind of the hard way to do it. The easier way to do it is to remember that it's always this. Okay? And the bottom one is always this. Notice it's a little similar to the difference of squares, only in the difference in sum of cubes, it's an AB in the middle, not a 2AB.
Yeah.
Okay, so what we're looking at here is that one.
Okay.
A is 2x squared, B is 3. So to square this, to me, the easiest way to do it is to immediately go to that and write a squared plus 2ab plus b squared, substituting what a and b are. So what do we have? What's a squared?
A squared, wouldn't that be just what's in the
What's a? Let's list a.
And would it be 2x?
It's 2x squared.
So you just keep it as it is in the...
Whatever that is, remember, that's plus this is what's being squared up here.
Okay.
Okay? So A is 2x squared and B is 3. Now put it together. In other words, you don't have to FOIL it, which takes longer, if you know these. So
okay.
What do we get?
Well, I guess you do it like the difference in squares.
Hold on. Yeah. What's that term right there is what I'm asking. What's the first term?
That would just be 2x squared, right?
Well, what is that? Remember that it's in parentheses. So give me an answer to what 2x squared is.
Would it be 2x to the 4th now? Or no?
4x to the 4th.
Oh, 4x to the 4th? Right.
Yeah, because you have to square both terms. In other words, you have to square the 2, which becomes 4, and you have to square the x squared, which becomes x to the 4th. Okay? What's the next term?
The next term would be 4.
Multiply a times b, and then multiply it by 2.
6x squared times 2 equals 12x squared.
Yes. That's the middle term. That's what 2ab is. And finally, what's b squared?
9.
All right. Now, I don't know if that was easier or harder for you than actually foiling it. Once you learn this technique, it's easier, believe me. And so I kind of teach everybody it just because you have to do it so often. So here's what we have on the left side. 4x to the 4th plus 12x squared plus 9. And now multiply that out, which is a little easier. You can just distribute that directly. The right side.
Alright, so I dropped my phone a second.
Okay, I was wondering whether we had lost our connection there.
It was just, yeah.
Do you have your phone up to your ear, or do you have it on speakerphone on a table?
My arm wrap, my charger doesn't reach very far.
Oh, okay. That's a tough way to do it. It would not as tough as it would be for me because I have to be doing all this writing. But you should. I would almost prefer you not be doing this on pencil and paper, just because I'd like to see you verbalize it and tell me what your process is. It helps.
Okay, got it.
So if you distribute the 4x to this binomial, what do you get?
You get 4x to the 4th and plus 18x.
24x. 6 times 4 is 24. Okay, now we can do a lot of canceling and a lot of moving, and what are we going to end up with here? The goal was to solve this thing for x, right?
Yeah.
Okay, well, what's the first thing we can do that makes it a whole lot easier problem?
Combine like terms.
Well, you see this 4x to the 4th and this 4x to the 4th? Whenever you see a situation like that, where they're not being multiplied by anything, you can just immediately subtract 4x to the 4th from both sides.
Okay, yeah, that makes sense.
Now, we have a quadratic left. There's the x squared term, there's the number term, there's the middle term.
Oh,
What's
so
the next step? Well, the first step is to get it all on one side.
Yeah, so you just subtract the 24x.
And put it in the middle. And most importantly, leave it equal to 0. When I take 24x away, there's nothing left. Okay?
Yeah.
Now, to make this an easier factoring problem, let's take out a greatest common factor. What is it?
3.
Yep. So we now have 3 times what?
4x squared minus 8x plus 3.
Yeah. Whenever you're doing these kind of problems, it's always good to be remultiplying to make sure you got exactly what you started with. Okay. Now, what can I do with that 3?
Okay. What do you mean, which 3?
Divide the first 3 over here that I just factored out. I can divide both sides by 3, which basically gets rid of it, replaces it with a 1.
Okay, I didn't think of it like that.
Well, that's a good way to actually think about it. Whenever you have 0 on the other side, then I can get rid of any leading number, no matter what it is. If it was 17, I can divide both sides by 17. It doesn't change the right side. The right side always stays 0.
Okay.
Okay. Now it's a factoring problem that we hopefully can factor. I wouldn't think they would give you one that would require you to use the quadratic formula or anything. Let's take a shot at it. This should be relatively straightforward, I think. Yeah, it's going to work just fine. How do I factor this?
You put 2x for the
That's a good start. That's not necessarily going to be the solution. It could be 4x and x, but I always like to start with the factors that are closest together. 2 is closer to 2 than 4 is to 1. What are both signs? The next step in factoring is, what are both signs?
Well, you're going to have to get a negative 8x.
Hold on.
So probably double negatives.
Has to be double negatives. Let's think about this for a moment. The only way you can produce a plus sign in front of that 3 is if the signs are the same. They either have to be negative negative or positive positive. And so we know they're the same, and then you look to the middle term, which is negative, so they have to be negative negative.
Yeah.
Okay? I'm convinced that factoring is best done step by step, exactly like I'm doing it. Now you have it half done, and in fact, there's not much choice. There's only 2 factors of 3, so a 3 has to go there and a 1 has to go there, and that better equal the middle term, or got to go back and start from step 1 again. Now, to see if this is correct, you don't actually need to FOIL these 2 terms completely back together again.
So you do the inside and the outside?
Yeah, we're just going to check the middle term to make sure we got it right. Well, that's minus 6x. Outside is minus 2x. Add them together, you get minus 8x. Beautiful, we got it done. That's correct. And whenever you're factoring these more difficult ones to factor, and they're always more difficult when there's a number in front of the x squared, okay? That just inherently ups its degree of difficulty. Well, this step here is part of the process. You don't really know you have the correct middle term until you do this. So it's more than just checking. It's sometimes part of solving it. Now, what's the solution?
The solution, wouldn't it be plus 3 and plus 1 and 0?
No.
Would it be 0? No, because you got rid of that term.
Here's the way you get the solution. What we know is that that term times that term equals 0. The only way that can be is if this is 0 or that's 0. So that's how we solve. We set 2x minus 3 equals 0, which gives you x equals 3 halves. Or you set this one equal to 0. 2x minus 1 equals 0, which gives you x equals 1 half. One of those has to be true. Usually both of them are true when you're solving polynomials, almost always. But there are lots of other types of functions where one of these generally will not be true. When you get trig, you'll have trig functions where frequently you have extraneous solutions, absolute value signs, radical signs, all of those, logarithmic equations, all of those are liable to produce an extraneous solution. But in this case, and the way you prove it is you go back and you test each solution. Well, if I go back and I plug in 3 halves for x, that works. And if I plug in 1 half for x, that works. So both of them are true.
Okay. And this was for which spot? This was for 15 still, right?
That was, yeah, that was 15. And I thought there might be a shortcut where we wouldn't have to expand that, but there wasn't. And that was the best way. And it was only after we expanded that that the x to the 4th term dropped out, making it an easy quadratic to solve.
Yeah.
All right.
I don't think that wasn't that hard on the test.
All right. What next?
Let me just look.
I see 13. I'm not sure you did 13 right. What was your solution on 13?
For 13, I guess it was x equals 6.
It's plus or minus 6.
I think it was...
It's plus or minus is what it should be. Here's what we have. After we divide both sides by 2, we have this, right?
Was it the I also? Was it the imaginary?
No? So let's just talk about this for a minute. This is what we have after we divide both sides by 2, correct?
Yeah.
So now I take the square root of both sides, but when you take the square root of the right side, you actually get plus or minus 6. Notice that minus 6 times minus 6 is equal to plus 36. So if I really want to know what the square root of 36 is, 6 works and so does minus 6. And you will lose points if you leave off the plus minus.
Yeah.
For sure. You won't lose full credit, but you'll lose probably half credit. So I try to get students to remember that whenever, and it's not, this is not true. That is not plus or minus 6. What is true is that when you solve an equation by taking the square root of both sides, which is what we do here, that's when it's always plus or minus. Your start of your answer should always begin with a plus or minus out of your mouth. Okay? Whenever you're solving an equation by taking the square root of both sides.
Do you know how to do synthetic division?
I do. Let's do 16.
That one? Did I do that one?
Well, that's the harder one to do. Well, maybe it isn't. Maybe it isn't. They both need ghost variables. Okay. First of all, what do you put across the top on, I don't know, you tell me which one you want to do. There.
I don't know, let's just do 16.
Okay. Notice that 16 is missing an x term in this numerator.
Yeah.
You have to allow for that when you write the coefficients up top. So what's my first number I'm going to write across the top?
You're going to write for the synthetic division?
For number 16. Okay, I'll show you how to do it, and then you can do the next one. The first number is 1 because that's the coefficient of the x cubed. Minus 2 is next, and then 0 because that's the coefficient of the x term, and then minus 9. In other words, you have to allow for all powers of x. Now, in the box, what do we put? If we're dividing by x minus 3.
You have to put, well, it would be 3 would be the 0.
You put the 0, the true value of the 0, and if x minus 3, that would mean x would be 3, is the 0 there. Okay, yeah. Now, here's what you do. You bring, go ahead, if you know how, direct me, please.
Yeah, you bring down the 1, you multiply it by 3, and you put the 3, then you, I guess, add it, so then you get 1, and 3, and then 3, and 3 times 3 equals 9, and that cancels.
Well, that gives you 0. You still add it.
Yeah, but it just cancels.
Well, it produces 0, and this is important because there's a rational zero theorem involved here. If this were not a factor of that, you would not get a 0. You would get some number other than a 0. So producing that 0 is key. That tells you that x minus 3 is indeed a factor of that cubic equation. And what's left over? In other words, now we know that we have x minus 3 as one of the linear factors, and this is going to be a quadratic. What's the quadratic that represents the other factor?
The quadratic is going to be x squared plus x plus 3.
Okay. Now, so those are the two factors. So we've used synthetic division to divide it. And when you divide that by that, this is what you get, is this quadratic. Okay?
Yeah.
And that's the answer. And you don't, this doesn't factor nicely, so we can't really factor that easily without using, in fact, that looks, yeah, that's going to be a irreducible quadratic is what that's called. The only way this factors further is with imaginary numbers. And most of the time when you're doing synthetic division like this and you're breaking down a polynomial of third or fourth degree, if you get to a quadratic that can be factored, you do it. But if you get to an irreducible one, you leave it as a quadratic. Okay? So in this particular problem, this is actually the answer, but this is going to be a common practice where you're going to break down to find the zeros, and we have that on 18 and 19, is where we don't have to just factor it, we have to find all the zeros. Okay? Now,
did we do number 35?
Well, I don't know if I have that.
Did my mom not send it to you?
We're only gonna, yeah, she sent it to me.
Okay, good.
I got it. Okay.
I forget what I was thinking.
Okay. We can certainly do 35. However, let me warn you that 35 is going to be a 10 to 15 minute problem all on its own. And I
just do it from where I left off.
Well, okay, yeah, I guess. Yeah. Well, first of all, it's important to know what the possible zeros might be. It's going to be at least a 15-minute problem. Looks like you've actually done it correct.
I think what I thought what we're supposed to do is use a calculator to find the zeros, like find 1 0.
No, there's something in fact, I don't know, maybe that's what you were supposed to do, but I don't think so. In other words, this is an easy enough one that you can use the rational factor theorem and the zero remainder theorem. You have to apply both of those whenever you're factoring cubics or higher. The only way to do it is, if you don't have a calculator, is to use the rational factor theorem, which says that all potential numerators are factors of 1 and all potential denominators are factors of 2. So that gives us plus or minus 1 as a possible numerator, plus or minus 2 times plus or minus 1 as a possible denominator. So what we get out of that is either that is a rational factor or that is a rational factor. And you just start randomly trying them. And that's what you did. You started with minus 1.
Well, I used the calculator to find it.
Well, this looks like synthetic division. Oh, okay. So you know that minus 1 is one of the solutions.
He requires us he allows us to find, like, for this type of problem where it's,
okay, I'm with you now. I'm with you now. So you were told that minus 1 was a 0, and now you're dividing that into the quartic to see what kind of cubic you are left with. Well, it looks like, did you produce a 0 as your last step? I don't see the 0.
Yeah, I put a 0. I just canceled it out.
Oh, there's a plus 1 and a 1. Okay. Yeah, there's 5 terms in that top. Okay, I got it. So here's what we're left with. 2x cubed minus x squared plus 2x minus 1. What's that word say? How?
To find 0.
How to find the zeros on this? In other words, at this point, you're not allowed to use the calculator, right?
No, we're allowed to use it twice, so we're allowed to not use the calculator for it, as long as we show all our work.
So you have not had rational factor theorem, P over Q?
Yeah, he hasn't really taught us that.
Okay, I got you now. That's the way you would do it if you didn't have a calculator. You would do it this way. If you have a calculator, well, you can put it in and find all 4 zeros.
But if we do that, we get no credit. So.
Ah, okay. Well, when you find your first 2 zeros, you will have a quadratic left. In other words, go ahead and find another 0 and divide that second 0 into this cubic synthetically. Ooh, actually, there's another way to factor that cubic. Let's talk about that. Here, this is important. This may be the only way you've learned. Ah, I see why. This is a unique cubic. It lends itself to grouping. You familiar with grouping?
Yeah, well, he taught us grouping, actually.
Okay, well, if you put parentheses, the reason grouping works on this is because the ratio of this 2 to this minus 1 is the same as the ratio of this 2 to this minus 1. As long as those 2 ratios are the same, then you can group it. What's the greatest common factor that's coming out of that?
I guess it would be, for the first one, it would
yeah.
be 2x.
No, you can't factor a 2 out. You can factor an x squared out. Leaving what?
The 2x minus 1.
Okay. And over here I have a 2x minus 1. Now, this is something that's unusual for you, and that is when you can factor a greatest common factor out of this expression. But it's a binomial. It's 2x minus 1. Leaving behind what?
What?
Leaving behind what?
Wouldn't it be x squared plus 1?
Yep. Now you have your zeros.
Which would be like negative 1/2. No,
Positive 1/2. This one gives you positive 1/2. And this one gives you imaginary. Plus or minus I.
Yeah, or plus or minus. Couldn't it also be square root?
No, here's how you figure that out on the second one. Again, we've got all of this equal to 0. So I set this equal to 0, it produces 1/2. I'm going to set x squared plus 1 equal to 0. Well, that means x squared equals minus 1. Now when I take the square root of both sides, I get x equal plus or minus, are always the first words out of my mouth, and the square root of minus 1 is I.
Okay.
So your four solutions are minus 1, 1/2, plus I, and minus I. And imaginary solutions always come in pairs, conjugates. If 2 minus I is one solution, then there has to be a 2 plus I as another solution.
Okay.
Okay? So if they give you, say, I was one of the zeros, a really good thing to do here would have been to say, I is one of the zeros. Then you could have said, well, that means minus I is also a 0. Divide this polynomial by I, then divide it by minus I, and you will end up with this quadratic, x squared plus 1. You will end up with 2x minus 1 and x plus 1 as your two linear factors. Would have been a more clever problem than having you use the calculator precisely twice.
Could we work on 30, maybe? I remember that one was so difficult.
Sure. Whoops. Meant to do that.
I don't know if I actually did it right, but...
All right. You'll notice there's two things about this that are true. One is that's the sum of perfect cubes. Right? In other words, that's a perfect cube, and that's a perfect cube. A would be 3x, B would be 2. So if we wanted to, we could factor it and then solve it. But there's an easier way to do it. Whenever you can do the easy way, always do it. Well, move the 8 to the other side. So now I have 27x cubed equals minus 8. Divide both sides by 27. So now I have x cubed equals minus 8 over 27. And now take the cube root of both sides.
Okay, that's actually what I did.
Okay, and that gives you the cube root of minus 8 divided by the cube root of 27. What's the cube root of minus 8?
Wouldn't it be 2?
It's negative 2.
Yeah, then you could just make it imaginary.
Hold it. It's not. No. There's nothing imaginary about it. It's negative 2 times negative 2 times negative 2 equals negative 8. Therefore, the cube root of negative 8 is negative 2 only, not positive 2, negative 2. The cube root of 8 would be positive 2 only. It's not like square roots. When you take square roots, the answer is always plus or minus. But when you take cube roots of a negative number, you get a negative answer. When you take cube roots of a positive number, you get only a positive answer. So the answer here is minus 2 divided by 3, or minus 2/3. Okay, so you got all the way down to that step. Then you just have to take the cube root of each of these. And it helps to separate it into a different numerator and a different denominator, like I did. Makes it much easier than trying to find the cube root of 8/27.
That's true. And then I guess I didn't even do 31.
Okay. Yeah, I'm happy to keep going. You tell me how long you want to go.
Okay,
Do you have a test today on this?
not tomorrow.
Tomorrow? Okay. Well, you could also schedule a second appointment if you want to take a little break.
It's okay, because right now I have time, because I don't have class for a while because of an assembly.
Okay. So if we go 11 more minutes, we'll have gone an hour. If you want to do that, okay, we can do that. All right.
There's no more questions left that we haven't really covered.
I'm sorry, what?
Division, I already know how to do the long division, so I just haven't done it yet.
Okay. On the long division, you also have to use ghost variables. Exactly the same as you have to do it on the short division, or on the synthetic division. In other words, you need to put in plus 0x into that, into 32. All right, let's look at 31. Find the real number solutions of the equation. Well, notice that if I move everything to one side and set it equal to 0, I have an impossible quartic. I could factor out an x, but then I would still have a cubic, right?
Yeah.
And I'm presuming you can't use your calculator on this one.
Yeah, if you show your work, you can use it.
Well, you don't need to here, because notice what we're looking at. We're looking at that same thing that allowed us to group a cubic is going to allow us to group these. This coefficient of 1 to 6 is the same as 9 is to 54. So let's factor out a greatest common factor from the left, which would be x cubed, like that. And then if I do the same thing on the right, I factor out a 9x, leaving behind an x plus 6. Now look what you can do. And I can take that, turn that into a 2, and now I have x squared equal 9. What's the answer? Nope. What are the first words out of your mouth supposed to be? Plus or minus 3. That's very important. You don't want to lose a point on every one of those you do, because you have to do it a lot on these problems that I'm looking at here. What else? What's that? Well, it wasn't really grouping, but I noticed that that ratio was the same, which means I could have pulled those two terms to the left side and then actually grouped it exactly the same way. Now, I actually did lose a couple of solutions here. I would have lost a point or two on this. And I'll tell you why. In fact, I would have lost more than that. There's two more solutions. One is minus 6 and the other is 0. I should have done it the proper way. And the proper way is to move everything to the left. I made a classic error that I'm always warning students not to make. Boy, I'll tell you what though, you got to be very careful with this because you can still make a classic error. Okay? Now, first thing I'm going to do is factor out greatest common factor, right? That's what I'm left with. Now, I have a cubic that satisfies the fact that I can use grouping on it. Automatically, I know x equals 0 is one solution, okay? Just by looking at this, I know that x equals 0 is one solution. So let's get rid of it and write up here x equals 0. Now let's deal with this cubic. Now, this is going to be a little different than the last one, and here's why. If I merely take that cubic and put parentheses around the first two terms and the second two terms, not the same expression. If I do this, I do not have what I started with. I end up with a negative 54 because this negative sign has to be distributed to both terms. So when you put parentheses, when the middle thing that's being done is subtraction, like in this case, the moment I add parentheses, I have to change the sign on the plus 54 to a minus. Now, notice I've got the same thing I started with. I have x cubed plus 6x squared minus 9x plus 54. You with me? Very important step because you have to do it every time this is a minus sign. Now when you factor out greatest common factor, you get this minus, and I can factor out a 6 over here. So I get, I can factor out a 9. I was getting ahead of myself and thinking, well, I'm getting a different solution here. And I'm left with x plus
9.
I cannot group this. Sorry, I took you on a wild goose chase here. Notice why I cannot group it. It's because the ratios are not the same. In other words, here, let me back up a moment. Put that plus sign back there. Yeah, I mistakenly looked at this and thought that I could group it because I saw the 1 to 6 ratio. But this is a 1 to 6 ratio. This is a negative 1 to 6 ratio. And if that's the case, then you cannot group it. And I didn't make a mistake. Yes, I did make a mistake. That should be minus 54x. In other words, all along the problem was this. That's a minus sign. And it does lend itself to grouping. In other words, this is what the problem really is right here. Okay? Now you with me? Sorry to confuse you. But this is what it really is. And now I can factor out the 9 and I have x plus 6. And now I can get my solutions. In other words, now I factor out the x plus 6 and I'm left with x squared minus 9. Remember, I still had that x, so that's what I end up with. And that gives you x equals 0, x equals negative 6, and x equals plus or minus 3 as your 4 solutions. One thing to check for whenever you're solving these higher degree polynomials is that you have as many solutions as the degree of the polynomial. And in other words, we're looking at a fourth degree polynomial. We would expect 4 solutions. So when I did it the incorrect way the first time and only came up with 2 solutions, I should have been suspicious immediately. And then I realized my mistake and what I had done.
Before you go, could you just solve a couple just so I can have them for like reference?
I'm sorry, I didn't quite understand what you said.
Before you go, could you just solve a couple more?
Sure. What one?
9 and 32.
32?
Yeah, and 29.
Okay. 29 is a little different. Let's look at 29 first.
Do you think that which one? 26 is sort of weird, or no?
26? 26 is the difference of perfect cubes. I'm having a hard time hearing you, Sam. I'm not sure why, but it's getting a little distorted.
Is this better?
Much better.
So would you solve it by...
Which one are we talking about? I couldn't hear your numbers you were saying.
Oh yeah, my bad. Number 26, I just want to know if you'd solve it with the binomial and the trinomial. And if not, we can just go back to that.
Yes, I would. And in fact, I actually made a mistake on 30, not solving 30 that way. Notice that 26 is just an expression that they want you to factor. Okay, so 16x cubed is a perfect cube. 54 is not, 16x. Okay, let's look at 26. This is a key problem.
Okay.
If I try to find the greatest common factor, that's one thing. But what I would rather do is factor out a 2 even if it isn't the greatest common factor, because what that leaves is 8x cubed minus 27, and both of those are perfect cubes.
Okay.
Okay? So A is what?
Wouldn't A be 8x?
No. It's always the cube root of that quantity.
Oh, 2x.
2x. And what is B?
3.
Correct. So I'm going to turn that into, well, the difference of perfect cubes starts out with A minus B, so 2x minus 3. And then the next trinomial term is A squared, which is what?
2x squared.
Give me the final answer. It's not 2x squared. The final thing is 4x squared. In other words, you have to put parentheses around it and then square it.
Okay.
And that's how you get 4x squared. You can't just square the x term. And then what's A times B, and what's the sign in front of it?
Would it be 6x plus 6x?
Correct. And finally, what's B squared?
9.
Plus 9. And that doesn't factor further. And in fact, that is an irreducible quadratic. And the way I can tell so quickly is by merely looking at the discriminant. And if I look at the, do they want you to fully factor this down to the imaginary solutions also?
No, they just want you to factor it.
Well, but that's not specific enough. In other words, it depends. You've been taught how to factor into imaginary numbers, right?
Yeah.
So I could use the quadratic formula on this and have an x minus the I combination, the complex number, and an x plus the complex number.
But he hasn't really made us do the quadratic formula.
Okay. All right. So this is an irreducible quadratic, and typically you would not break this down anymore anyway. When you start with a cubic and you factor it into its linear terms, its constants, and irreducible quadratics. In other words, I cannot really turn that into two linear factors. It would involve complex numbers. So.
Oh yeah. Okay.
Okay. So that's the answer to both 26 and then I should have done it that way on 30. Notice that when I did 30, we only came up with one answer, minus 2/3. Well, there should be three answers, and there really are. It's just that the other two are imaginary. Okay, I said find the real solutions only. We found the real solution. We did 30 correctly.
Okay.
Long division. You want to do 32?
Yeah, I think 29. That's just pretty straightforward, right?
It actually, well, 29 isn't that straightforward. You have to kind of recognize that this is actually a quadratic. Doesn't look like a quadratic. It looks like a cubic, but it's really a quadratic. First of all, let's take out the negative sign, because it's always difficult to deal with a negative sign when you're factoring what appears to be a quadratic. Now, why do I say that's a quadratic? Well, if I let u equal x squared, then what I have up here is u squared plus 10u plus 2, right?
Yeah.
Well, I can use the quadratic formula on this. And it doesn't have rational solutions, but it certainly has irrational solutions.
Well, all we have to do for it is factor it.
Well, you can't factor this without using the quadratic formula.
Can you do it by completing the square?
Yeah, you can do that.
Because that's what we've been taught.
Okay. Yeah, okay, well, let's do that. Well, you probably haven't been taught factoring an expression by completing the square. You've probably been taught how to solve a problem by completing the square. But you need an equation for that. In other words, 29 is not an equation. 29 is an expression. And we can still factor it by completing the square, I suppose. But, all right, let's do it. Because completing the square is certainly something that is extremely important to be able to do. But in order to complete the square, let's pretend that it's an equation and equal to 0. Okay? Now here's how I'm going to complete the square. First of all, I can get rid of that negative sign. I'll just divide both sides by -1. And I'm going to move the 2 over. So I got u squared plus 10u equals -2. Now I'm going to put parentheses around that and complete the square. What do I need to add here to complete the square?
25.
Plus 25. Since I'm adding it to the left, I got to add it to the right. Now I can write that expression as a linear term squared. What is the linear term squared going to be?
Isn't it going to be 5?
U plus 5 quantity squared. Whenever you are completing the square, you're doing it with the goal in mind of being able to write it as a linear term squared. Okay, and that's all equal now to 23. Now it's relatively easy to solve for u. Take the square root of both sides. Subtract 5 from both sides. And there's your solution for u.
Why u?
Well, because what I started with was a quartic. And you're not used to, and what u is x squared. So if x squared is equal to this solution, then wow, what is this problem doing on your review material? This is, I mean, we can do it, but maybe I'm thinking about it wrongly, but I don't think so. In other words, there's no way to factor that directly. There's only one way I know of to factor it, and that is to turn it into a quadratic in u, which I did, and then either use the quadratic formula or complete the square. The quadratic formula, incidentally, was derived from completing the square. That's how they got it. So you can use either method to solve, to figure out how to factor this and solve for u. Well, I did. I solved for u. That's what u is equal to. Well, what does that mean? Well, u was equal to x squared, so x is plus or minus the square root of u, and u is this super complicated thing over here. This is actually called a solution by radicals. In other words, here's what we have. Minus 5 plus or minus the square root of 23, all under that radical sign.
Yeah, I've never seen this.
Okay, I'm not surprised.
How about we just go to like 32 and you can just like solve that for me so that I can like make sure I'm doing it right.
All right.
And then
that truly, if that was an equation, that's the only way I know how to solve it, is by solution, by u substitution and turning it into a quadratic. And it is a quadratic. It's a quadratic in x squared. But let's look at 32. All right, I've got 3x squared plus x. That's all I need there. I'm going to do long division, so I got to make sure here I have every power of x covered. And there's a missing x, so I got to add it as a 0x plus 5. Now, the first step in long division is to always divide that term into that term. What do you get? 2x.
No, 2x.
Okay. Now the next step is to multiply this by both terms. So I get 6x cubed plus 2x squared, and now subtract. Long division is always subtraction. Synthetic division is always addition. That's why it's a little easier. But
so you just multiply the second term by the...
Right. In other words, you divide the first term into the first term, and then you multiply your quotient times both terms, and then subtract. Well, when I subtract that, that goes to 0. When I subtract this, I got minus 2x squared. Minus 2x squared gives you minus 4x squared. Bring down the next term. Stir and repeat. Okay, now 3x squared goes into minus 4x squared.
Negative 1.
Yeah, excuse me. And then multiply the negative 1 by both terms. And subtract, and you end up, where did I go wrong here? x minus a minus x is 2x. Can't have that remainder. You know what? Here's where I went wrong. I was actually doing it correctly. This is a fraction. It's not 1. If I use 1, then it's actually, when I divide 3x squared into minus 4x squared, I get minus 4/3. And then when I multiply minus 4/3 by that, I get minus 4x squared minus 4/3 x. And now subtract, that goes to 0. This becomes 4/3 x, and that is the remainder. And you treat a remainder by adding it. So I have 4/3 x divided by my original divisor, 3x squared plus x. Now, there's nothing wrong with that answer. They're going to give you this hard of problems, then you should be able to give fractions as part of the answer. And I believe that's the correct answer. I could go into Wolfram Alpha right now and do this on Wolfram Alpha, or on your calculator you could do it. Unless I made a arithmetic error, when I don't think I did, or copied something wrong. Yeah, there's nothing wrong with that answer. And in fact, I can factor an x out from the bottom. And then the x disappears, and you end up with a number as a remainder over x plus 1. So you end up with 4/9, 4 over 9 times x plus 1. Divide using polynomial long division. So what I did, I don't know another way of doing it. Okay? Now that final answer is, in other words, if I factor out this remainder, factor out an x, what do I have? I have x times 3x plus 1, and then that x cancels with that x. I can put this 3 in the bottom, and I end up with 4 over 9x plus 3. There's your remainder. 4 over 9x plus 3. But that would be the quotient with that remainder. This is the remainder. Surprised they would give you one that has a remainder, and that it wouldn't end up being perfect without a remainder. You know what I'm saying?
Yeah, I know. It's a lot. Yeah, I think we're good now. That pretty much covered everything.
Okay, Sam. That was quite a session. Those were some tough problems.
Yeah, I know. It's a tough class.
Okay. I will talk to you next time.
Hey, Dave.
Yes.
Hi, it's Sam's mom. How are you?
Good. How are you?
Good. Thank you so much for doing this for him. And we're just, I don't know what your availability is in the mornings like this.
It's pretty good. It's pretty good in the mornings. Not so good in the afternoons, especially this time of year. But I'm usually available in the mornings, so feel fine about asking me to do an 8 o'clock session. I have no problem with that.
Okay, yeah, he has a couple mornings, like I think it's Tuesdays and Thursdays, that he doesn't have to go in till a little bit later.
I do. I'm happy to do.
Okay, so yeah, we'll be calling you because this is great, and we're just trying to get him on track
Yeah.
for the rest of the
So
semester.
sorry, I didn't get your email till I got up this morning, but I get up usually around 7. So.
Okay. Well, we'll try and be on it a little.
And you can communicate with me by text also. I might get that a little quicker if it was something like your
Perfect.
communication last night. All right, sounds good.
Okay. Thanks so much.
All right.
And I'll take care of it on PayPal for you.
Okay, I'll just charge you for an hour and 15 minutes at $32 an hour. So what is that? That's 32 plus 8, so that'd be 40.
Okay, fabulous. Thank you so much.
You're welcome. Talk to you next time. Bye-bye.
Bye-bye, dude.